Hello, my name is Manav. This is Unit 1, Lesson 12 of Algebra 1 or Integrated Math 1 Honors, Average Rate of Change of Functions. So this is a new topic, so I would strongly suggest watching the videos before this one, so videos in lessons 9, 10, and 11, before you step into this. So if you do not have a strong understanding of what a function is and how to identify a function and figure out if something is a function versus isn't, I would definitely go ahead and brush up your skills on that. So just make sure that you strongly understand what a function is, and if you don't, check out my previous videos or find some other person to help you double and triple check that you understand this topic. So here's some new vocabulary, which is rate of change. You might see this as an average, you might see this as per, you may have seen this before, but you might just not know it's called the rate of change. A rate of change is how much a function's output changes relative to its input over a specific interval. Essentially, it means how do the values change from point A to point B. It's also known as a slope, so you're most commonly going to be seeing this as slope, but if your teacher has like a trick question of some sort, you may see this as rate of change. Think of it as a slope. That's what it's normally called, essentially. And here is our formula. You may see both of these. You're more likely going to see this, but I thought it would just be nice to include this one over here. They mean the same things. If you did not understand that, then just go to the previous video as well, because I do explain why this and that are the same. But essentially, this is our formula. It is the second y value subtracted by the first y value over the second x value subtracted by the first x value. The rate of change is a measure of change between the 2 points. And our 2 points are x1, y1, as well as x2 and y2. And that's how we would set them up here. I will show you in a few examples what I mean by this. And this works because f of x is a fancy version of y. And the x values inside of f of x, so b and a, those are x values. Even if they're not x, they are x values. They refer to the actual x value. So in this case, it's b and a. I'm going to use this one for most of the examples only because it's a simpler formula. It's more common. More people see it and remember it more oftenly. There's 4 ways to find the rate of change. You have when you're directly given the points. You have when you're given a table, when you're given a graph, and the hardest one is when you have an equation. So when you have points and you're asked to find the rate of change, the points are given directly to you, and your goal is to use the numbers and plug them into the formula and just get that answer out. So here's how. Find the rate of change, which is ROC, between the points 1, 8, and 5, 12. First, we have to identify x1, y1, x2, and y2. And I do that down here. I rewrote the numbers from up here, down here, and I just associated each one. So keep in mind that you get to choose whatever gets labeled as which, but if you choose one value as x1, that y value in that coordinate point has to also be y1. So this does not work. You cannot have that. You can't have x1 and then y2 in the same coordinate. It doesn't work. It has to be x1 and y1. And why doesn't that work? That's because if you were to use this one as x1 and this one as y2, that means that the number 1 is associated with the number 12, which is not true. The number 1 is associated to the number 8. Think of these subscript numbers as differentiators, so it'll make one set of numbers different from another, because if you think about it, x and y repeat. So this just tells us, oh, it's referring to this number, and oh, it's referring to this number. It's so that we don't get confused. That's why it has to be the same. So this, we can call this point 1, and this we can call point 2. And that's why we have a 1 next to the things here, and we have a 2 next to the things here. So now that I've identified x1, y1, x2, and y2, and explained why x1 and y2 aren't the same thing, you can't have different numbers in the same coordinate, we're gonna plug the numbers into the formula and just solve. The formula is y2 minus y1 over x2 minus x1. Keep in mind that the 2's line up with the 1's. They're not interacting, they're not crossed with each other, they are directly on top of each other, and y is before x. So when we write our formula and we just plug back into the equation, we got y2 is our first number, which is over here. Y1 is our second number, which is up there. X2, x1. And when we solve, essentially what we do is we do 12 minus 8, which is 4, divided by 5 minus 1, which is 4. 4 divided by 4 is 1. So that's why our rate of change, also known as slope, for this equation and problem and points is 1. So essentially this means that when x increases by 1, when x is between 1 and 5, according to our points given, y will also increase by 1. So for example, we know that 1, 8, and 5, 12, which means that when x is 2, so x is 1 above 1, so 2, y is also going to be increasing by 1 from before. So here, let's draw it out. Our original number is 1, comma 8. We know that when x increases by 1, which is 2, y also increases by 1, which is 9. And similarly, if x is equal to 3, y will add 1, which is 10. X equals 4, y adds 1, which is 11. And if it adds again, we have 5, 12. If you have not recognized, this is the same number that is up here. So hopefully that makes sense on what the rate of change is. It's saying that whenever you increase x by 1, the y value will increase by the slope. Now let's go on to how we find it in a table. So this is what a table looks like. We have our x's on one side, and then we have our y's on the other side. Find the rate of change of the table during the interval 2 and 7. So essentially what this is saying is that we're solving so that we can find how much y increases whenever x is in between the numbers 2 and 7. And in case you need a refresher, I do talk about this in one of my other videos. When we have a table, it's essentially saying that the coordinates are x value and then y value. X value and then y value, x value and then y value. So essentially these are the coordinate points that are being expressed by the table. It's just in a different format. So we're finding 2 and 7 because these are our two x values. We have x1 is 2 and x2 is 7. Now that we've identified x1 and x2, which is our first step, we have to identify y1 and y2. Remember that x1 and y1 have to be connected. And if x1 is 2, y1 is going to be whatever 2 is next to, which is 5. So y1 is 5. And then same idea for 7. If 7 is x2, whatever's with 7 is going to be y2, which is 30. We use the numbers 2 and 7 because that's what's given in our equation. 2 is the minimum and 7 is the maximum. 2 is the smallest that x can be, and 7 is the biggest that x can be. This will make a lot more sense in our graph example, so just hold on tight if you do not understand this yet. But we are given that 2 is an x value and 7 is an x value, and we can find 2 and 7 in our table. We know that when we say have these signs down here, we know that 2 and 7 include x, so that's why we can use them. And when we continue to solve it out, where we get 5. So essentially what this means is that whenever x increases by 1 and only 1, y will increase by 5. So I'll write it out again. We started with 2, 5. When we add 1 to x, we add 3, we add 5, which is 10. If we do it again, we have 4, 15. And if you look here, 4, 15 is a spot on our table, which is why this works. Now let's go to our graph. Find the rate of change between the interval of -6 is where -6 is greater than or equal, less than or equal. Find the rate of change between the interval where -6 is less than or equal to x, which is less than or equal to 2. So I drew it out here, and this is going to relate back to the table on why this makes sense, where 6 is our least value and 2 is our biggest value. So as you see here, here's our graph. I might do another color. As you can see here, this is our graph. This is the point that we are worrying about. We don't care about all of this. We are only caring about the place in between the red and the blue. So we have to find the rate of change, which means when x increases by 1, how much does y increase by in these two lines. Now that may make sense now that you have a graph, and that hopefully clears up the table. So again, our first step is to identify x1, y1, x2, and y2, and then plug into the formula and solve. As we see here, when we've got -6 and 2. When our x is equal to -6, which is right here, our y is equal to 2. And same with that logic over here at 2. When our x is equal to 2, which is here, our y equals 2. So our coordinates are -6, comma, -2, and 2, comma, 2. If we give each one an identification, and we plug into the formula like we've been doing a countless amount of times, we end up with 2 subtracted by -2 divided by 2 subtracted by -6. This is basically saying 2 plus 2 divided by 2 plus 6, which is 4/8. That gives us 1/2, which means that whenever x increases by 1, whenever x is in between -6 and 2, y increases by 1/2. And lastly, we have our equations. We have to solve these using function notation. So if you don't understand function notation, I would go back and watch this video again. Watch the lesson before this one, and make sure that you have function notation solid. So our first is to identify x1, y1, x2, and y2. This is our equation, and we have to solve this using function notation. Right now, we have x1 and x2. It's given to us. We'd have to find y1 and y2. And we have to use that by using our x values to sub into our y values. And remember, The last number is just to differentiate one x from another x. So don't get confused. These are still x, but it's just different x values. So it's different x's, so we don't confuse one x with another x. So when we solve for y2, we're using x2 because those are the same category. They are the same value. And we continue, when we solve it out, we have f of 6 equals 3 times 6 plus 2, because this is our original equation. F of 6 equals 18 plus 2, which is 20, which makes y2 equal to 20. Following the same logic, we use x1 or 1 to find y1. If we continue solving it out, we have f1 equals 3 times 1 plus 2, which is 5. And then we have y1 equals 5. And then we set up our formula like we have been doing. Y2 is 20, y1 is 5, x2 is 6, x1 is 1. And then when we do that, we have 15 divided by 5, which is 3. Our rate of change is 3, which means that when x increases by 1, when x is between the numbers 1 and 6, y will increase by 3 than what it was at before. Hopefully that you understand that. And I want to go back to the graph for a second. Now here's a quadratic function. This is another function that you're going to learn about heavily later. If I were to ask you to find the interval between here versus here, those are going to have different rate of changes, as you can see. Now, for any function that's not a straight line, you're going to have different rate of changes for different areas. Now, for a linear function, you're going to have the same rate of change throughout the entire thing. This because it's a slope. When you learn about identifying linear functions, you'll understand that this is the slope and this is how you calculate it. Now let's go ahead and do some practice. Find the rate of change between these two numbers. First, we have to identify x1, y1, x2, and y2. So let's just go from left to right. x1, y1, x2, y2. Then we set up our formula. Our formula is y2 minus y1 divided by x2 minus x1. 24 minus 7 divided by 12 minus 5 is this big number. So, which means that whenever x increases by 1 between 5 and 12, y will increase by 2.429. Now, this just brings me to say that your rate of change isn't always going to be a perfect solid number. It could be a number like this. So keep that in mind and make sure that you're not confused by that. Now we go over to our table. Find the rate of change of the table during the interval 4 is less than or equal to x, which is less than or equal to 28. So we have 4 here and we have 28 here, which means that the coordinates that we are working with is 4, 8 and 28, 36. Again, we're just going to go left to right to identify x1, y1, x2, and y2. x1, y1, x2, y2. Our formula is y2 minus y1 divided by x2 minus x1. And when we solve that out, we get 1.167, which means that when x increases by 1 in between 4 and 28, y will increase by 1.167. Lastly, we have to find the rate of change of the graph during the interval -4, where it is less than or equal to x, which is less than or equal to 6. Now, this might be hard, but as long as you look at it step by step, it should be pretty simple. So first, let's find where -4 is on the x-axis, because it's an x. Our x-axis is here, so -4 would be here, which comes in line with this one right here, where our y value is 6, which means that one of the coordinates we're dealing with is -4, 6. Using the same logic, we find 6 on our x-axis, which is here, and that just happens to be at 0. So the two numbers that we are dealing with, or two coordinates that we are dealing with, are -4, 6, and 6, 0. Now make sure that you understand that you have to be using the 2 points that we are talking about. So essentially, we are finding the rate of change, and it's going to look somewhat like this. So we do not care about the yellow outside at all. We only care about from here to here. Hopefully that makes sense. We do not need to talk much about this yellow. The yellow doesn't essentially play too much of a role right now. If we were trying to find the rate of change from these two and we ignored that, then yes, we follow the yellow. But we're going to ignore the yellow. We are just going to follow this white line here. That's our rate of change. So again, we're going to identify x1, y1, x2, and y2. We just go from left to right. And when we plug this into our formula, we have y2 minus y1 over x2 minus x1. That gives us -3, which means that whenever x increases by 1 from -4 to -6, y will decrease by 3. Not the greatest graph to show you exactly, but hopefully you get the idea. Lastly, we have an equation. Find the rate of change of this equation when given negative 2 is less than or equal to x, which is less than or equal to 7. Remembering back from what we talked about before, this is our x1 and this is our x2. These are x values that we can use because they're included, that's what this sign means, they are included between our formula where we're talking about for x. So where we're going to find y1, we're going to use this number, and when we're going to find y2, we're going to use this number. So this is for y1, where we use negative 2 because that's x1. And we're just going to replace all the 2's, or all the x's with negative 2's, where we get negative 10 plus 14 equals f of negative 2, which is equal to y1, which is 4 equals to f negative 2, which is equal to y1, where y1 equals 4. And we're going to repeat that process for x2, or 7. Okay, as you can see, y2 is equal to 49 and y1 is equal to 4. So we're just going to set this up like normal. y2 is 49 minus y1, which is 4, divided by x2, which is 7, and x1, which is negative 2. And when we solve that out, we get 5, which means that when x increases by 1 in between the numbers negative 2 and 7, then y will increase by 5. Hopefully you understand this, and this makes a lot of sense, and thank you so much for sticking around. This is Unit 1, Lesson 12, Average Rate of Change of Functions for Algebra 1 Honors or Integrated Math 1 Honors. Thank you.